In section 3.1, we introduce functions and a set of input and output values called the domain and range, respectively. In this section, we'll learn how to determine the domain and range of a given function. The title of this section is just the domain and range. We'll go ahead and break this section down into 5 different pieces. In part A, we'll be looking at set notation. In part B, we'll be looking at interval notation. In part C, we'll find the domain and range of graphs. In part D, we'll find domain and ranges of common functions. And then in part E, we'll be looking at piecewise functions. In these first 2 sections, we introduce language that will allow us to express the domain and range of functions. Then these next parts are the main content of the section. And then in the last section, these piecewise functions, we introduce these objects because they appear in many different applications where you have multiple pieces of information that show up. Before we get to the content of the section, let's go ahead and review the idea of domain and range, and then also provide some motivation. So recall that a function acts on input and produces outputs. So for example, here we have a function that assigns our input values to some output values. And once we have this here, the set of all input values is called the domain of the function, and the set of all output values is called the range of the function. So I'll go ahead and write this down, and then we'll move on to the motivation. So here's the definition of domain, and here's the definition of range. Great, so we'll go ahead and use a common motivation which is found in physics. And let's go ahead and suppose that we have a position function of a projectile that gives us the height of the projectile at any given time. And now the question is, what is the domain of this function, and what is the range, and what does this tell us about our physical system here? Well, let's go ahead and look at the domain real fast. When t is equal to 0, we have that the height of our projectile is 0. So if the projectile starts at a height of 0 feet, and then it goes up into the air, at some point it's going to hit the ground again. So let's go ahead and find the other value at where our projectile is going to hit the ground. To do this, we need to set our height function equal to 0 and then solve for t. So as we saw in the last section, we need to figure out what this t is in this equation over here. So we can go ahead and pull the t out to the left-hand side, and we'll get t times the negative 16t plus 96 is equal to 0. So in one case, we already see that t is going to be equal to 0, and in the other case, we need to find what t is for the following equation. but we can just go ahead and solve for t, and what we'll see is the other value of t is going to be 6. So let's go ahead and start a new page. What this tells us is that at time is equal to 0, our projectile hasn't left the ground yet, and then at time is equal to 6, our projectile hits the ground. And in this particular case, the domain of this function is going to be all the time in between the time that the projectile leaves the ground and the time that the projectile hits the ground. And because we know how to graph polynomials, we know the height of our projectile is going to look something like this. And so the domain of this function tells us when the start and end of the projectile trip occurs. Okay, so what about the range? In this case, the range is just telling us what height occurs at any given time.